my name is Ansh Chabra, and this is my Lab 3 on magnetic field of a bar magnet. The purposes of the lab were to observe the relationship between distance and magnetic field, and to use the Biot-Savart law and the distance dependence of magnetic fields to find the bar magnetic moment of a bar magnet. The models and fundamental physical principles were the Biot-Savart law, which is shown below, and the distance dependence of a bar magnet. The main results of the lab showed that the magnetic moment of the bar magnet was 2.645, and the n calculated was negative 2.7705. This slide describes the procedure of the lab. You want to distance any electronic devices to reduce their impact on the experiment, and then place your smartphone on the table. I'm not going to go over the procedure in detail because they're all outlined and it was outlined in the slides, but basically you use the bar magnet and try and calculate the on and off axis magnetic field using the magnometer app on the phone and placing the phone at different distances throughout the lab. This slide illustrates the procedure as well as this slide. And this procedure shows how to find the magnometer on the phone. The assumptions of the lab were that the magnetic field of a bar magnet isn't affected by external electronic devices, and that a bar magnet acts as a magnetic dipole so that we could use the Biot-Savart law. The initial conditions were a bar magnet and a smartphone having the magnometer app, and the system was a bar magnet while the surroundings were everything else. Here's some of the data and calculations. It shows the on-axis magnetic field and the graph of the natural logs of the magnetic field and the distance. And from the slope of the graph and the y-intercept of the graph, you can determine the n value and the ln of k value, from which you can determine the value of k. And then you can use the two equations illustrated and set them equal to each other, which you can use to solve for the magnetic moment of a dipole, the magnetic moment of the bar magnet. Here was the off-axis magnetic field data. Some of the code here shows the creating of the magnet on the left side. Additionally, it creates a Biot-Savart law as a formula in the code, which can be used for the modeling in GlowScript. And some of the code on the right creates vectors to show the magnetic field at different locations relative to the bar magnet. The last part of the code codes to visualize the magnetic field 45 degrees off of the axis, and the GlowScript model at the right shows the magnetic field at different locations on and off of the axis. Some of the theoretical data gave that the magnetic dipole moment of the bar magnet was 3.89 times 10 to the negative fifth, while the experimental gave that it was 8.16. And although the data and model produced relatively different values, the model well predicted the data because there were very little discrepancies in the data and the model. Some possible sources of error were the location of the magnometer being not correctly determined, the reading of the magnometer not matching Earth's magnetic field, or electronic devices in the vicinity skewing the magnometer data. What if we had oriented the experiment to compensate for the magnetic north? If we didn't do that, then the results would be much less accurate because Earth's magnetic field would interfere with the magnometer readings. Additionally, if we were to stick two identical magnets together, then the direction of the magnetic field would have remained the same, but the magnitude of the magnetic field would have relatively doubled. Thank you.